Hello everybody, welcome to Mathethics original channel. Thank you for watching our videos. Please don't forget to like, share and subscribe. In today's video, we will solve system of two linear equations with two variables using the method of substitution. So let's begin. Giving the following system, 4x plus 3y plus 3y equal negative 40 and 5x minus y equal negative 12. How do we solve this system using the method of substitution? So the idea is, first thing to do is to select any of these two equations and solve for any of these two variables. So you can choose the first equation, which is 4x plus 3y equal negative 40, or you can use the second one, which is 5x minus y equal negative 12. It doesn't matter which one you choose to work with first. And then you can choose to solve for x, or you can choose to solve for y. It doesn't matter. Okay, so now I'll suggest that you select the equation that look easier to deal with. Avoid fraction as much as possible. So in this case, since I have y with no coefficient or with a coefficient of negative 1, so that make it look easier to solve for y in equation 2. Okay, so the reason I say it's easier, like if I look on the first equation, x have a coefficient of 4, y has a coefficient of 3. And on the second equation, x have a coefficient of 5, and y has a coefficient of negative 1. So whatever variable does have a coefficient of 1 or negative 1, to me is easier. So because of that, I'm going to choose the second equation and I will solve for y. Okay, solve for y in the second equation. So 5x minus y equal 12. To solve for y, we have to subtract 5x on both sides of the equation. 5x. Then we have 5x minus 5x is 0. We have negative y equal 12 minus 5x. We cannot combine these two. Now, we can divide negative 1 on both sides of the equation. So we divide everything by negative 1. And that will give you y equal negative 12 divided by negative 1. Negative 12 divided by negative 1 is positive 12. And negative 5x divided by negative 1 is positive 5x. Okay. Now that we have y by itself, so what we're going to do is substitute the value of y in the other equation that we didn't use. Okay, so we're going to substitute the value of y in the other equation that we didn't use. So what's going to happen, we're going to take this value here, 12 plus 5x, we're going to take that value and then we're going to substitute it over here for y. Okay, so we're going to have 4x we're going to have 4x plus 3. Now, instead of putting y, we're going to have 12 plus 5x. 12 plus 5x equal negative 40. Now, if you realize we have one linear equation with only one variable. So now we can just go ahead and solve for x. So we got 4x plus, now in this case we have to use the substitution, the distributive property, so we can get rid of the parentheses. So to use the distributive property, we're gonna have 3 times 12, and also we're gonna have 3 times 5x. So 3 times 12 is 36, and 3 times 5x is 15x equal negative 40. Now we can combine a term, which is 4x plus 15x is 19x plus 36 equal negative 40. Now, if we subtract 36 on both sides of the equation, so we're going to subtract 36 on both sides of the equation, minus 36 minus 36. So we're going to have 19x plus 36 minus 36 is 0. So that's gone. So equal negative 40, negative 36 is negative 76. Now, we can go ahead and divide both sides by 19 in order to get x by itself. Divide by 19 and divide by 19. So if you divide by 19, on the left side, you can have 19 divided by 19 is 1. So you got x by itself, and negative 76 divided by 19 is negative 4. So that is the value for x. Okay, so now that we have the value for x, since we are solving the system, we need to find the value of both variables, which is the value of x and the value for y. So what we can do, once you got the value of x, you can substitute that value in any of those three equations, either on the first equation or the second equation, or that equation right here that we found on the first step. Okay, so I can take that value of x and substitute it here on the first one, or here on the second equation, or I can go ahead and just substitute it over here. Either way, I will get the same answer. So what I'm gonna do, I'm just gonna substitute x on this equation right here from step 1. Okay, so I'm gonna have y equal (12) plus 5 times 4. So 5 times negative 4. X is negative 4. So we're going to have 5 times negative 4 is negative 20. So we're going to have y equal 12 minus 20, which make y equal negative 8. Now, when you're writing your solution, you have to write it, the x value and the y value. Okay, so the solution is negative 4 for the x value, and then negative 8 for the y value. So that is the solution for that system. Okay. Now, considering that we have this following system, y equal 2x minus 4 and 3y equal 3y plus 21x plus 21x equal 15. We have the following system of equations. So notice that in this system we already have y isolate by itself on the left of the equation. So there is no need to solve for anything. We can just go ahead and start by substituting the value of y in the second equation. Okay, so like I said, we got y equal to x minus 4. So y is already by itself. So we don't need to solve for y or x because y is already by itself. So what we're going to do, we're going to take that value of y. Okay, we're going to take this y value right here and we're going to substitute it for y on the second equation. Okay, so let's do that. So we have 3, instead of having y, we're going to have 2x minus 4 plus 21x equal 15. Okay, now we need to get rid of the parentheses by using the distributive property. All right, so we're gonna have 3 times 2x, and we're also gonna have 3 times negative 4. 3 times 2x is 6x, and 3 times negative 4 is negative 12, plus 21x equal 15. Now we can combine like term. 6x plus 21x is 27x. Okay, 27x minus 12 equal 15. Now we're gonna go and add 12 on both sides. We're adding 12 here and we're adding 12 on the other side, and we have 27x, that is 0, negative 12 plus 12 is 0, and 15 plus 12 is also 27. Now we can go ahead and divide both sides by 27. That's 27 divided by 27 is 1. So we got x equal 1. Now that we have the value of x, you can go ahead and substitute the value of x in the first equation. Since we didn't use it, we haven't used it yet. So we're going to substitute the value of x in the first equation. Now, it doesn't matter if I substitute it in the first or the second equation. Okay, so I can substitute x over here, or I can substitute it over here. It will give me the same answer. But since this first equation look simpler, more simple, so we're gonna just go ahead and substitute it in the first equation. So we're going to have y equal 2 times x is equal 1 2 times 1 minus 4. So 2 times 1 is 2 minus 4. So therefore y is equal to 2 minus 4 is negative 2. So y equal to negative 2. So solution is 1 and negative 2. Okay, that's it. Now, let's say we have x equal negative 1 minus 2y, and we also have 3x plus 5y equal negative 1. Notice that just like the previous example, on this example we already have x by itself. Okay, so since we already have x by itself, we can go ahead and start with the substitution. Okay. So what we're gonna do is we're gonna take this value right here, we're gonna take this x and we're gonna substitute it over here in the second equation. Okay, so we're gonna take the value, the expression of x from the first equation, and we're gonna substitute it in the second equation. So what we're gonna have is 3x 3. So now instead of having x, we're gonna have negative 1 minus 2y plus 5y equal negative 1. Now we can go ahead and solve for y. Okay, so we have one linear equation with one variable, so we're solving for that variable. So to solve for y, we need to get rid of the parentheses first, and to do that we have to apply the distributive property. We're going to do 3 times negative 1, and then we will do 3 times negative 2y. 3 times negative 1 is negative 3. 3 times negative 2y is negative 6y plus 5y equal negative 1. Now we can combine like term. Negative 6y plus 5y is negative y equal negative 1. Now, we need to get rid of that negative 3, and to do that, we're going to add 3 on both sides. So, negative 3 plus 3 is 0, so that's gone. So you have negative y by itself equal negative 1 plus 3 is 2. Now, because we need y instead of negative y, so we're going to divide both sides by negative 1. Okay, which imply that y equal negative 2. So that's the value for y. Now that we have y, we can take that value and substitute it in any of these two equations from the original system. Okay, so since I need to find x now, I'm gonna substitute the value for y in the first equation. So we're going to have x equal -1 minus 2 factor of -2. Okay. Which equal -1. Now, -2 times -2 is +4. So +4, and that's equal to 3. So x is 3, y is -2. So your solution is 3 and -2. So that's the solution. So that's when x is 3, y is -2. All right. Now, let's say we have the following system. Y equal 2x minus 13 and y equal x minus 5. Notice on the system, on both equations, you already have y equal. And that's very important. So if you already have that same variable isolate on both equations, then you can just go ahead and set both of them equal to each other. So which means you're going to take this one right here to x minus 3 and make it equal to x minus 5. Alright, so that's what we're going to do. So 2x minus 13 equal x minus 5. Now, all we have to do is solve for x. So to solve for x, we're going to first subtract x. We're going to move all the x value on the left side of the equation and everything else on the right side of the equation. So we're going to solve, we're going to subtract x on this side and also subtract x on this side. So now we have 2x minus x is x minus 13, and over here is 0, so equal -5. Now we can go ahead and add 13 on both sides, and we got x, -13 plus 13 is 0, so x equal -5 plus 8 plus 13 is 8. So we got x equal 8. Now, we can go ahead and take the value of x and substitute it in any of these two equations, either this one or this one. So I'm going to go with the second one because it's look easier. So I'm going to have y equal x, sorry, we know x is 8, so we're going to have 8 minus 5. So 8 minus 5 is 3. So y is 3. So your solution is 8 and 3. Here is another example. Let's say we have x equal y minus 1, and we also have x equal -2y plus 8. That's look similar like the one we did before. If you check on this equation, on this system, on both equations, they already isolate x. Okay, so x is already isolated on both equations. So with that being said, we can just go ahead and take this one equal to that one right here. So let's go. We're going to have y minus 1 equal negative 2x plus 8. So I'm going to put y over here, y over here. So y minus 1 equal negative 2y plus 8. Now, we're going to solve for y. So we're going to start by first adding 2y on both sides of the equation. So we can move y on the left side of the equation. We're going to add 2y, and we're going to add 2y here. Y plus 2y is 3y minus 1 equal 8. Now, we can go ahead and add 1 on both sides. Okay. And now we have 3y. Negative 1 plus 1 is 0, so that's gone. And 8 plus 1 is 9. Okay. So I'm going to carry this up here. So we have 3y equal 9. Now we can divide both sides by 3. And we have y equal 3. So now, what we can do is take that value of y and substitute it in this equation right here. Again, it doesn't matter whether you go ahead and substitute it here or here. It doesn't matter. You get the same answer. Okay, so I'm going to substitute on the first equation. So we're going to have x equal, now the value of y is 3, so we're going to have 3 minus 1. 3 minus 1 is 2, so x is equal to 2. So your solution is x is 2 and y is 3. Now, let's say we have x equal 5. And we also have 2x plus y equal 10. In this system, as you can see, the first equation is the value of x. Okay, so there is nothing to do. You already have the value of x. So all you have to do now is take that value of x. So we know that x is equal 5. Okay, so x equal 5 is the solution. Okay, now what we're gonna do is we're gonna substitute the value of x in the second equation. Okay, so we're gonna have 2 instead of x, we're gonna have 5. Okay, 2 times 5 plus y equal 10. 2 times 5 is 10 plus y equal 10. And we subtract 10 on both sides. Then you're going to have 10 minus 10 is 0. 10 minus 10 is 0. So we're going to have y equal 0. So the solution here five and 0. Okay, let's do one last example. So you have 2x plus 8y, 2x plus 8y equal 20. And we also have y equal 2. Again, that's a system. So in this case, the second equation is the value of y. So all we have to do is take the value of y and substitute it in the first equation. So we know y is equal 2. Now what we need to do is substitute 2 for y in the first equation. So we're going to have 2x plus 8 factor of 2 equal 20. So we got 2x, 8 times 2 is 16 equal 20. Now we subtract 16 on both sides. Then you have 2x equal 4. So 16 minus 16 is gone, is 0. So you got 2x equal 4. Now, we divide 2 on both sides of the equation. Then we have x. 4 divided by 2 is 2. So we have x equal 2. So the solution is 2 for x and y is also 2. Okay, so that's the solution for this system. So thank you for watching our video. If you have any question, any comment, any suggestion, or any feedback, please let us know in the comment. And I will see you for the next video.